This video is about my journey through moulding boxes. This is what it started with. A piece of skirting board left over from the building of our house in 1952. I certainly learned some lessons in making boxes, in particular just how hard it is to make a decent wooden box that'll sit flat on a bench. I've cut that piece of skirting up and now I've started to screw it together to make a box. And this is the way here that most people screw their boxes together. This one is inside both of these two. Now this has a bit of a problem. It shows the difficulties of making a box, that unless you are very precise in cutting these ends square, the box won't sit right on the bench. And in fact, this one rocks. And that's typical. That means that when you strike it off the sand mould across the top of here, it's not going to be flat. It's probably not going to mate with the other box half very well. There'll be a bit of a gap around there for half the border. When you sit it on the floor, it won't sit flat. You sit it on a baseboard, it won't sit flat. Eventually I came to the conclusion that the better way to do it is like this. Here we've done the joints differently, and just at the moment with one screw. Later on I'll put a couple more nails and things like that in, but now because it can pivot around the screws, any errors in here or in here or in here or in here can be evened out. All you've got to do is hold it down flat onto a flat surface like this and do the screws up, and you get a box that just simply will not rock at all. It's dead flat, and that's the way it should be. I've now taken one half of the box, drilled a couple of holes in it that are slightly undersized on the diameter of a 3-inch nail, chopped a bit off 2 3-inch nails, and driven them in. So I've got a couple of very crude dowel pins, and this is what I did the first time all those years ago. Using these two bits of wood as a guide, I'll just simply sit this down here as evenly as I can get it. And give it a bit of a tap with a queltometer here. And now I'll go and drill these slightly oversized on the nail holes. It pays to drill them vertically, so if you've got a drill press, use it. Okay. Now, if I've done this right, this should sort of go together. There we go. It's a bit tight, and it may be necessary to sort of wear it in a bit, or maybe even get a slightly bigger drill and enlarge the bottom holes a bit. But there basically is the basis of a box. Now, one thing about the pins, I find they're best along the long way on the box. It just seems to me to be easier to lift a box like that, because your hands should always be where the pins are, and if the pins are here, it just seems way more awkward and wobbly to lift like that. Much easier to lift like this. The other thing is the pins, if you draw a line between them, that line should go between the centre of weight of the box. If your pins are, say, down here, when you're trying to lift, the whole thing's going to try and do that. If the pins are, say, here and here, you're going to have a terribly wibbly wobbly situation. So always keep them in the middle, even on a crude, rude box like this one. And that basically is the first moulding box I used. I made, for example, a lot of these. Now, what's wrong with this box? Well, there's a lot of things. First of all, there's not very much guidance as you lift one half off the other. So that means it's going to be difficult to do patterns that have got a lot of height on either side, unless they're split patterns. Split patterns are a bit more work to make. With something like this, which is pretty thin, there's only half that amount in lift, so you can get away with it. But it certainly has its limits, a box like this. You use your hands to do most of the guiding, to be honest, and as you get a bit more skilled, you can do work that's higher, but better pins are definitely an advantage. Because there's one more point I'd like to bring out with these wooden ones. Here I've relied upon this little rebate in the back of this skirting board to provide the key to hold the sand in. Now you get away with that with a little box like this, but as the boxes get bigger you need something better. You got to remember that the area that holds the sand, if you double the box, will double, but the weight of the sand will actually go up 4 times, and eventually it becomes too great for that and it will just fail. It's only got to fail across that little bit of sand, so it's not all that strong. Now this comment of course applies mainly to the sand I use, which is a natural green sand. Petrobond sand seems to be an awful lot stronger, and it does seem to hang in boxes better from what I've observed on YouTube. I've never used it myself. So all of the boxes you'll see, other than that very first one that I've made, will have 2 keys like this, top and bottom of the box, so the sand can't fall out either way. It doesn't matter whether you turn the box upside down or not, it can't fall out. I see some people using 1 key in the middle like this. I don't like it much because there's only that distance there that the sand has to fail, or there rather than there, so that is not as good or as strong a method of holding the sand in as the double key that I normally use. Following my rather pathetic efforts at making this my first ever box, of which this is a replica, a friend who was helping me with my casting endeavours and was also a very skilled pattern maker, decided to make me a box. Of course, he had some decent equipment where he worked to do it. All I had was a handsaw and a square. So he made me this. Knocked it up in one of his lunch hours. Of course, it's only got very simple wooden dowels, but it does have reinforcing in the corners, and it's a reasonable box. It has some problems. First of all, you can't get your fingers under the lugs to lift the box apart. So when that's full of sand, that's very awkward to do. Secondly, of course, the lugs don't give you real good alignment. It all rattles around a bit. And then the material's a bit thin and the box can flex. You see, there is a bit of flex there. And when a box flexes like that, it's a bit prone to dropping its load, as it were, and you can lose your mould all over the place. So with that in mind, he made me another one. Again, no doubt in his lunch hour. And this time, as you can see, the wood's a bit thicker. It's still the same construction. It's got all the lugs to hold the sand in, the reinforcing in the corners. This time we've got a bit more space between here, so it's now possible to get one's fingers in. Again, just the simple wooden dowels, but this time we've aided it a bit with these to give us some guidance until the dowels sort of take over. And that made for a slightly better box, but still really both of these are only suited to moulds, or patterns rather, that are split, or you've got to be damn good at lifting boxes or you lose all the edges. While we were doing that, we thought, okay, we'll try one of these tapered boxes. As you can see, it's bigger here than here. The brilliant idea here was that after we rammed it up, we'd give it a bit of a tap on the bench and then just lift the box off the sand, tap it again and lift that off, be left with a lump of sand sitting there on a base plate. And we pour that and we go away and make another mould in this, sort of like you do with a snap flask. Stupid idea in my opinion. Now, I then went ahead and made this box. Sort of patterned a bit on the ones the pattern maker had made, but of course I didn't have his skills and I made a couple of silly mistakes. First of all, these, the reinforcing in the corners, don't come right up to the edge of the box. So after you've rammed it, you've got this little patch of sand here that's very weak and frail, and it tends to fall off and go inside your cavity and generally make a devil of a mess. I didn't have any dowels on this box, I just used these things. Now, a lot of people on YouTube seem to use them as their location, but really, they're absolutely terrible. First of all, if you grab the two boxes and move them, you can see how much slop there is. It's just not a good system. And even worse, wood moves as it absorbs and rejects moisture as the weather changes. And you find that these suddenly go loose and you've got to pack them here. You know, I've used business cards to do this. Sometimes you find it gets too tight and you have to actually sand bits off here or off here. Terrible boxes. I also learnt that these boxes really were a bit on the big side, but before we get to what I then move to, we'll have a look at the even bigger ones I made. Oh dear, now I'm really getting into the archives. There's a bit of dust up there. Oh boy, is there ever. I made these fairly crude boxes in response to the necessity to make a couple of big jobs. So this box, when it's full, I couldn't lift it. I could roll it, but I couldn't lift it. And I actually had to mould these on the floor. It was just too much. I could lift one box, probably couldn't anymore, but when it's full. Again, no dowels, just these useless things. The boxes are starting to get pretty thick this way. Now, as boxes get bigger this way, it's like a beam that holds up a roof. It has to be thicker that way or it just won't do. And you have to remember that. There's a trick you can use to get around that, and we'll get to that shortly. Now, whilst I had those, I made this, my first metal box. And without doubt, the worst casting I have ever made. It was just with a very crude no-taper pattern, and we had a bit of fun getting out of the sand, and as a result, as you can see, it's a pretty rough casting. But to make matters even worse, when I cast it, I used 4 of these on the corners like this, and I poured down one of them, but the metal I used was absolute rubbish. And if you look, these little defects you can see, they are actually gas in the metal. And I noticed when I poured it that the metal didn't shrink down these, it actually expanded up them. And you can see why. This is one of the feeders. I have kept it all these years as a reminder of just how bad a casting can get. That is probably in part, the bigger bubbles are probably in part air from the turbulence through the lousy pouring, but most of that is gas that's precipitated out on the rubbish in the metal. This metal, I think, was melted down swarf, a lot of oxide skins, and this is the result you get. I realised I needed multiple boxes. They needed to be the same size and preferably metal because the wooden ones kept getting burnt. So I made a pattern for these, for this one and one about this much longer as well. And then I methodically and painstakingly cast all these in sand. Mark the centres of the bolt holes there with a little jig I made up, and then I could bolt them together in this manner. Now with the 2 different sizes, I was able to make up a box like that, fairly obviously, a box like that, or of course a box like that. So I had a fairly useful range of boxes, or at least I thought. But there was a lot of problems with these boxes, and in the end I abandoned them. And as we'll see later, I rather threw the baby out with the bath water. But the first thing that was wrong with them, they're too thick. That's a good 4 inches there, a good 100 mil, and it just makes the whole box too high, too much sand, too much weight, and I never really needed a box that high. When you do, I can extend the feeders 20 or 30 or 40 mil, as I often do, but I would never extend them by the bean can full of sand that sadly I see so many people doing. But there were other problems too. Again, the 2 pin areas are together and you can't get your fingers under them. I thought I'd be able to lift the box by the ridge, but really you still need to get your fingers down where the bolts are. There, that's all right, that's better. To do it right. So that was a problem. It's nice to be able to get your fingers under there. That was problem 1. Then there was the problem with the pins themselves. What I had done, I thought, oh, I'll be smart. I'll drill and tap these 3/8 Whitworth, and I'll get some 3/8 bolts, and I'll make a pin like that. Just turn the head of the bolt off in a lathe or with a grindstone or whatever. Terrible idea. Unfortunately, I didn't have decent equipment, so I couldn't guarantee that these holes would be tapped in vertically. Secondly, a bolt like that, the chances of the thread being dead parallel with the shank, not exactly brilliant, not in a cheap, nasty bolt. The net result, and the other thing, of course, is that being threaded, when you screw them home, when the thread finally goes home, it kicks the bolt over a little. So the only way these boxes could work was with the pins a little loose, and that meant that there was slop in the box. So that was a bit of a disaster. I even went to the trouble of making these pins up. Now these, they're bigger, 1/2 inch, which is a much better size. I turned them up in a lathe, and I threaded them while they were in the lathe, but it still didn't help. They still slop around on the thread, and you still need to work with them loose. While they're better than those, they're still not really good enough in my opinion. So with that, I just abandoned these boxes, threw them, cast them aside, and moved on in my mind to something else, which, as we'll find out later, was a bit of a pity. Also with these, well, I made up a little jig to drill these. It wasn't a very good jig, and I didn't get them drilled that accurately, and in the end I had to use oversized holes. It worked, and I do use these boxes, but very, very occasionally. And they were made out of rubbish metal, that's whatever I had at the time, and that may have been a bit of a mistake too. But interesting, you'll notice that these have never been machined on the top edge. I was able, well, this one has, they even tried that in desperation, but most of them haven't. You can still see the feeder attachment points, gate attachment points here, and all I did was just run a file over the part line, which you can just see around here. And this was an advantage, because this means that these are possibly the basis for a box that you can make without having to have a milling machine to flatten them off later. And we will see that in part 2 of this video. One of the things that I said was wrong with these boxes was that they were too deep. Uses a lot of sand, makes a heavy box, etc, etc. Takes a long while to ram it. So in sort of desperation, I then made up about another 40 of these so that I could make a box that was a little bit, just a little bit more than half height. Mainly used it as a drag box, and it was sort of successful, but yeah, not really. The problem with these boxes with the pins was sort of a bit off. In fact, that pin there, probably as I turn it, you can see that it kicks, the thread's not square with it. So they were terrible, so I just, as I say, I abandoned those. With some of the problems of those last boxes in mind, I then made these. Again, they're all sand cast. One at a time. I made 11 of these boxes, or 10 and a half, which means that there's 84 sides, and it took quite a long while to make them, I assure you. For these, I used 1/2 inch pins, the good hard steel pins. They're actually Thompson shafting. One of the problems with those pins is that they're soft steel. They're just normal steel, and that tends to stick in the aluminium. It also tends to corrode a bit more than the hard steel does. These make good pins, and these boxes are screwed together. After I cast them all, I went up to a friend's place, and he had a horizontal milling machine, and we were able to sit the sides up so that they're machined in here. There's a flat on this side that matches the flat on the end of this, and the box goes together beautifully. And then I drilled and tapped and put little 1/4 inch bolts in. I altered the pins, how the pins hold, and also how the where is one? Here we go. And this is the first time I actually seriously used the slot, and we'll go around, we'll look into why that slot's necessary in a moment, or when we deal with another box. These holes were drilled under a drill press, and they were lovingly reamed in this case to a light press fit, or you warm the box up and drop them in. And in this case to just a nice clearance, and these were cut with a milling cutter mounted in a lathe at the time. These boxes I have done an absolute ton of work with, and almost an unbelievable amount, so much that the ones of these that was originally cast here wore too much, and I've replaced it, in this case with a bronze angle, and in this case with something a bit more sophisticated. And indeed, in the end, some of the round holes wore too, and there I've done the same thing, put a bracket and actually bushed the hole, and that worked quite well. These were a much more successful box, still had the mistake of these being a bit too close to the parting line, but I've used them a lot and got done an awful lot of work with them. Sometimes when they weren't quite right, I'd extend it with this, just sit that on top and ram the mould a bit higher. But these work very well. There's almost no play in that box at all. There might be a couple of thou in that, and that's about it. And yet they come apart beautifully, and they, as I say, were a great box over many years. Following that, I made these up. Similar design. This time I didn't sand cast them. I made a little gravity die up, and I cast each of the sides in a gravity die, and I think I made 160 sides in 1 or 2 days casting. Again, they were taken to a friend's place and put on his milling machine so that the corners here were all milled nicely and flat and straight and square. And again, I drilled and reamed the holes for the pins, for the fixed ones and for the loose ones. And again, where are we? The slots were cut using a milling machine, using a milling cutter mounted in the spindle of a lathe. Now, why do I use slots? One end. Well, for a start off, this end controls the box moving that way and the box moving that way. This end controls it only moving that way. Don't need to control it that way because this pin does it here. But this means that I can pick up any one of my 10 boxes and it will fit. You don't have to be extremely precise with how far apart the dowels are compared to how far apart the holes are. Now, if you just had holes either end, the distance between would have to be to within 2 or 3 thousandths of an inch, and that's not easy to get over that sort of 10-inch distance. In fact, it's very, very difficult indeed. Any box fits any box. The odd sides I use, I'll get one. Here's an odd side I use for making the throttle bodies. And the idea is here, again, the same hole and slot arrangement, and every pinned box fits this same odd side. And in fact, I had 5 or 6 of these odd sides for different throttle bodies, and every box fits every one of those various odd sides. The other thing, of course, is that if the box gets a bit damaged, this pin might move a bit in relation to that one. And that happens from time to time. You get thrown around a bit. So again, the slot will take care of that. And I say to you now, do not use 2 holes. Use a hole and a slot, and your life will become an awful lot easier. Now, I also made a bigger version. And again, it's the same deal. Hole and slot. And here's a pattern plate that makes 6 of, I don't know what it was actually. Oh, a little stand that went on a dashboard, I believe. Oops, a bit tight now. But again, every one of these big boxes, and there's 10 of those, fits this same pattern plate. And it just means I can go ahead and bang out moulds lickety-split without having any real problems. There we go. The other thing about these pins you'll notice is that they are on in the middle of the box this way. That means that when I pick them up, there's no tendency for them to tip that way because there's more sand over here. Also, they're as far apart as I can get them on the box. That one needs to be replaced. A little bit of slop, few sour there. If they were here and here, the slop would be worse. So they want to be as far apart as you can get them on the box. You want to be able to put your hands where they are to get a good lift. And that way, you're not fighting weight anywhere, you're not fighting drag of pins. You try and do it like this, and I've seen some people do this, the pins tend to grab and you wind up in a hell of a mess. It's terrible. So, golden rule 1, pins as far apart as possible, pins in the centre of weight of the box. Lift the box by putting your hands where the pins are, and there's 3 golden rules for you. In moving to these boxes, one of the most notable things is the bigger and longer pins, and the fact that the lugs that hold the pins and the lugs that hold the holes for the pins, or the slots, are in the middle of the box. Now, this might seem a bit odd, but it's really not. First of all, the greater length gives you a lot more guidance as you go, and that's a great help. Particularly if you're doing work that's not split pattern, and most of my work wasn't split pattern. But the other thing about this box is that you can pin them this way, and this isn't all that clever sometimes because it's a bit hard to lift the box that way, but it allows you to do this, and I've suddenly made a 3-high box. In fact, if I really want to, I can keep going. I can make it a 4-high box, if it'll fit. It should. And that, again, is the advantage of the slot and hole arrangement, that every box fits every box. And I've never used 4-high, I must admit, but I have used a 3-high like this quite a bit, and it's a handy ability sometimes. But it does rely on the longer pin. This is another example of a box. It was actually built just for the one job. I built 2 of these boxes, and this was the job. It's I believe, a manifold adapter plate, fits on V8s or something of that order. And the whole idea was that the pattern plate fits on the pins. The same pattern plate fits both boxes because it's got a slot that end rather, and it'll lift off quite nicely and leave the impression in the box. When boxes get bigger, and this is really why I'm showing this box, there is a tendency for them to flex across there. And if they flex, they'll drop the sand. So what you do is you reinforce the box. Use a bit of all thread will do, but it's got to have a nut on either side. And that holds the box together and stops that flex, and you much less likely to drop your much less likely to drop the sand out. Now you have to move these along a bit to get around things like sprues and feeders, etc. But it is a technique worth remembering if your boxes start to get big. Now here we've used these steels as bits of steel as a rough sort of a guide, but the final closure, the final location, of course, is done by these 2 hardened pins. And again, they're quite long pins, so they give some guidance, so you can clear the pattern. And they also, of course, over that way. Also, you can put your thumbs on the top of the pins and just lift the pattern plate nice and evenly, and it works quite well. But I don't like working with boxes like this. They are just too damn heavy.